Welcome to another session on signals and systems. We are working problems on classification of signals. So in the previous session, we have seen problems on periodic and non-periodic signals, problems on energy and power signals. In this session, we will see problems on even and odd signals. Let us first of all understand or recollect the even and odd signal. So when we call a signal x of t to be an even signal if x of t is equal to x of minus t. That means the signal, when it is reflected or when it is folded along y-axis, is same. There is no change. Then we call the signal as even signal. That means it should be symmetric about the y-axis. Next, odd signal, we say that x of t is equal to minus x of minus t. Then we say that the signal is an odd signal. This we can also write it as minus x of t is equal to x of minus t. That way also we can write it. Simply to keep in terms of x of t, we write this as x of t is equal to minus x of minus t. So this is an odd signal. For any signal, we can compute the even and odd components by using the formula. The even component of the signal x of t is given as xe of t is equal to half of x of t plus, half of x of t plus x of minus t. So you add these two signals and take half of that, or the average of those two signals. Similarly, the odd component xo of t is given as half of x of t minus x of minus t. All right, now let us take some problems. Find the even and odd components of the following. So we have to find using the formula. All right, so this is the given signal x of t. Now, when we want to find x of minus t means simply you can just see that we are simply folding the signal. So when we fold the signal which exists from 0 to plus 5, when we fold along the y-axis, this signal will go and sit this side. So therefore, it will look like this. Let me draw. Yeah, when we fold the signal x of t for x of minus t, it will look like this. So this will be from 0 to minus 5. All right, so this is x of t, and this part of the signal we call it as x of minus t, x of minus t. All right, this is x of minus t. Okay, now that is how we understand, but the amplitude remains the same, 4. So we hope we understand how we find x of t and x of minus t. All right, so therefore this is x of minus t. This is x of minus t. This is x of t. When we see, is there anything common between? Nothing, because x of t exists from 0 to 5 and x of minus t exists from minus 5 to 0. In the limit minus 5 to 0, this signal x of t is 0, and in the limit 0 to 5, x of minus t is 0. So when we add these two signals, so the result will be, so we are using the formula xe of t, that is the even component of the signal, is given by half of x of t plus half x of minus t. Therefore, the amplitude, which was 4, is now reduced to 2, and the signal will be like this, which exists from minus 5 to plus 5. So you add both these components and you have got the even component of the signal. All right, we are simply adding these two. along the time axis. So what is the signal present? Next, if you want to find the odd component of the signal, so this is x of t. So we have to find minus x of minus t. So I have told you how to find x of minus t. So you take x of minus t. How we get x of minus t? When we fold x of t along x-axis, oh, sorry, y-axis, we get x of minus t. Now, how do we get x of, minus x of minus t? We have to fold the x of t signal, whatever we have got. We have to fold along the y-axis. So when we fold it along the y-axis, let me show how it will look like. Okay, so when we fold along this axis, so this signal will now look like this. So this is minus x of minus t. So when we, so to get x of minus t, we fold the signal along y-axis to get minus x of minus t. So we go to the signal x of minus t and we fold the signal along along x-axis to get minus x of minus t. So therefore, we get the signal. This is minus x of minus t by folding this along the x-axis. So now this is x of t and this is minus x of minus t. So the formula to compute the odd component is you have to add these two and take the average of this. So therefore, when you add these two signal, you get an waveform like this, and the amplitude of 4 is now reduced to half of it. That will be equal to minus 2 and plus 2 for this limit minus 5 to plus 5 time unit. All right, so this will be the odd component, and previously we have found the even component of this signal. All right, so the problem is a lot more easy when they have given in the graphical form. Okay, the next we will take, similarly, they have given a exponential decay signal. So as I said, it's an exponential decay signal. It starts at t equals 0, has an amplitude of 4 and goes on decaying up to, so it is a exponential decay signal. So if you want to find the, by in a similar way how we have computed the previous problem, you can find the even component, and this will be the even component. If you find the odd component, this will be the odd component. So this is x of t plus x of minus t. This is x of t minus x of minus t divided by 2. Here also it is divided by 2 because we have take the average of those two signals. So we have found the even and odd component for the discrete time signals. Now let us take, the continuous time signals. Now let us take a discrete time signal x of n. So this is the graphical form. If you have to write this in the function form, this will be equal to, it has a constant amplitude of 1. So, and the signal starts at n equals 0. So you can write this as u of n, x of n equals u of n, but u of n will have an amplitude of 1, but this signal has an amplitude of 4. So therefore, this signal x of n will be equal to 4 into u of n. Now, 4 into u of n means it will have a constant amplitude of 4 starting from 0, n equals 0 up to infinity. But the signal does not exist up to infinity. It ends at n equals 5. I mean, not n equals 5. At n equals 6, the signal ends. That means it exists up to 5. So therefore, the signal which is given in the graphical form can be represented in the function form of x of n equals, sorry, this is not, yeah, x of n equals 4 into u of n minus 4 into u of n minus 6. N minus 6. Again, here I cannot take it as u, simply u of n, u of n minus 6, because u of n minus 6 will have an amplitude of 1, but we want the amplitude as 4. So therefore, it is 4 into u of n minus 6. So amplitude of plus 4 and minus 4 will subtract from n equals 0 onwards. So therefore, we have written the graphical form in the function form also as a practice. Okay, now this is a given signal. We have to find the even and odd component. So we are using the formula. The even value is equal to half into x of n plus x of n minus x of minus n. So this is x of n and x of minus n. By simply folding and then add those two and divide it by 2, we get x of n and xe of n. Very similar to what we had done in the continuous time domain. Similarly, the odd function of this will be x of n plus x of n minus x of minus n, the sum of that divided by 2. So the amplitude has become 2 and minus 2 in this region. So therefore, we have found the even and odd components of this signal. Very similar to the previous problem, we have taken one more example, and this signal also is a finite signal, and we are finding where the even and odd components of the signal. So what is the even component? By using the formula, we have found the even component as this and the odd component as this signal. Similarly, let us take some more problems which is given in terms of a function form. They have given in function form. How do we find the even and odd components? Previously, we have seen the graphical form. Now let us take the problem on function form. So this is x of t is equal to e to the power of j to t. What is x of minus t? You go to the function, replace t with minus t. So therefore, x of minus t will become equal to e to the power of minus j to t. So what is xe of t? It is half of x of t plus x of minus t. So when you add these two, e to the power of j theta plus e to the power of minus j theta divided by 2 is, by Euler's form, it is the cos theta. So therefore, this is cos 2t. Similarly, what is the odd component? You will get j sine 2t. So therefore, this signal is a complex exponential which has sine and cos. So cos is an even term and sine is an odd term. So therefore, we have found the even and odd component of this signal x of t given in the function form. Next signal x of t is equal to cos omega naught t plus pi by 3, where pi by 3 is a phase angle, and we know cos signal is a even signal. So let us find what is the even and odd component of this given signal. So x of t is equal to cos omega naught t plus pi by 3. X of minus t will be equal to cos, that is minus, you have to apply minus t. So therefore, we can get this as cos omega naught t minus pi by 3. What is the even component? So it will be cos omega naught t plus pi by 3 plus cos omega naught t minus pi by 3. So that is half cos omega naught t we will get. Next, the odd component of this signal will be root 3 by 2 sine omega naught t. So this will be the odd component of the given signal. So therefore, we have found the even and odd components. Now let us take another problem, x of t, and find the even and odd components. So we will find what is x of minus t by replacing each t with minus t. So here this will be minus t whole square will become plus t, and minus t whole cube will be minus t cube. and we find out what is the signal here. So therefore, okay, so this is the even component of the signal, 1 plus t square cos square 10t, that is the even component. Similarly, we can find the odd component, and the odd component turns out to be t cube cos square t. So in simple terms, the even powers starting from t power 0 is 1. So the even powers are even terms and the odd power are odd. That way also we can take this problem. Okay. So we have seen how to find the even and odd components of any given any signal so far. Now, given a signal and they ask us to check whether it is an even signal or an odd signal, they are not telling us to compute the even and odd components, but simply telling us to check whether it is an even or odd signal. So we are going to find out like this: x of t is e to the power of minus 3t, and x of minus 3 minus t is e to the power of 3t. So when we see x of minus t, so we find out what is the signal. So this is x of t is not equal to, so we see that it is neither even nor odd. So we can check whether the given signal is even or odd or neither. So therefore, here x of minus t is not equal to minus x of t. So therefore, it is neither even nor odd. Similarly, if they have given a graphical form, this is in the function form to check whether a given signal is even or odd. Now, if they have given in the graphical form, we know that this is an even signal because x of t is equal to x of minus t. So that means if you fold along x-axis, sorry, y-axis, the signal is symmetric. Therefore, it is an even signal because x of t is equal to x of minus t. So this signal, the third signal, is an odd signal because if you take x of minus t, this signal will, as I said in the previous case, the signal will look like this. This is x of t, this is x of minus t. So and then when you fold along the x-axis again, this signal will go and sit on this. So therefore, this is an odd signal. So from this understanding, we can say that the given signal is an odd signal. So far we have seen problems on classification of signals. We have seen problems on periodic and non-periodic signals. We have seen problems on energy and power signals. We have also seen problems on even and odd signals. In the next session, we will take up worked examples on signal analysis using vectors. Thank you.